So what do you actually need for ambient IoT? You need a harvester, you need a PMIC, and a wireless SoC that's not going to eat all that energy. Hey, it's Eamon with ipXchange. We're here at Wirepas OPEN 2024. I'm here talking with Tristan from Silicon Labs because they've kind of blown our mind a little bit, because we've talked about Dracula Technologies before, we've talked about EPs before, and they are working with both of these technologies. So Tristan, first of all, just give our audience a little bit of information about who you are and what you do with Silicon Labs. I don't think Silicon Labs themselves needs an intro. And then, yeah, let's get into this concept of ambient IoT.
Let's do that. Absolutely. I'm glad you notified that. We're really the missing piece to this equation here. Both Dracula and EPs are big partners of ours. So my name's Tristan Cool. I'm a product marketing manager at Silicon Labs. And essentially, I'm leading our energy harvesting and our ambient IoT journey here, developing new chips, as well as adding these features to our existing chips. So that's why I'm here today at Wirepas Open discussing our exciting product.
Cool. So for those of you who weren't here, Tristan actually gave like a big keynote speech near the beginning of the event, all about the new MG22E series. So Tristan, can you explain the MG22E and some of the specifications it has that makes it so good for ambient IoT? Possibly we should also, for those of our audience who don't know, just explain the concept of ambient IoT. I'm sure many of them do know, but that is a good point.
Yeah, okay, so I can answer that swiftly here. So the 22E is a derivative of the 22, which is a Bluetooth, Zigbee, proprietary 15.4 part. And what we've done for the ambient IoT, as the name would suggest, it relies on ambient energy. So when you say the term energy harvesting, it implies a different set of hardware. It implies solar panels or vibration harvesters that harvest the energy. When you talk about ambient IoT, it's the radio and the MCU that use that energy. So it's kind of the second part of the same equation. So what the 22E does very well is for these asset tracking or smart home devices that are conventional IoT devices, really the beautifully simple optimization here is the sleeping current, the waking current, and having the lowest protocols. So we've been able to reuse a lot of our existing platform examples, our existing customer base, and make sure we're compatible with partners like Dracula and EPs to take a battery solution and render it battery-less.
Nice. So in terms of, I remember you saying in the speech there was stuff to do with how low the RX? Oh no, let's cut that. That was Nordic, I think, with the RX.
It's the same story, honestly. It's a radio, right? So radios are either scanning or listening. Or beaconing or listening. And in asset tracking, you have to do both. So if I put the whole thing together, right? An asset tag needs to wake up, needs to start beaconing, needs to listen, and then go back to sleep. And then repeat endlessly. So each of those steps need to have the absolute lowest current. So in the 22E, we have a low reception current, very low transmit current, low sleep current, and an extremely efficient wake-up current. So that puts it in perspective what those different values do. And it comes down to how long you're doing each. If you're sleeping for a long time, if you're listening for a long time, that's what ambient is all about, is optimizing dynamically how that works.
Cool. And I guess for those of people who haven't really thought about ambient IoT before, they're going to be thinking, well, there's lots of batteries out there. Why don't I need batteries? So can you give the key, I guess you could say green argument for ambient IoT, but there's also like just a sheer cost of maintenance for battery IoT.
Absolutely. Everyone agrees that asset tracking is the fastest growing space. And you look around us, everyone requires a battery. So I think my go-to is there's 900,000 tons of batteries disposed of, 15 billion batteries a year. So I'm questioning how sustainable and how scalable this industry truly is. So yeah, people are taking note about why batteries are not the sustainable approach. And our lead customers really care about that. I know the green agenda is attractive, but our largest industrial customers choose their vendors based on who's the most sustainable. And we're the first of many to do something similar.
Nice. So for our engineers out there who really want to try out the 22E, I can see there's a little board here. How does it work, and does it plug into one of your other boards?
Exactly right.
Nice.
Yeah, so I'll walk through we call it a reference design, right? But essentially, the barrier to enter energy harvesting and ambient IoT can be quite daunting. The rate of adoption of abandonment is quite high. So we've made sure our kit is simple. It takes an existing sample kit that we have here, an Explorer kit, and it uses a shield. So using our partners Dracula NEPs, his solar panel or other energy harvesting solutions, you socket it right on top.
Cool.
We have a new set of firmware examples that have been optimized for energy, and we've made it simple. Because typically when you design a device, you have a hardware team and a firmware team. And for something as complicated as energy harvesting, those two teams need to be very much in sync, and the tools need to be easy. So this is a reference design. It's a very cute shield. The part comes out in a few months. That's why I don't have it in front of me. I wasn't allowed to bring it with me.
Nice.
But if you ask me again in a few months, I'll have one with me. And yeah, that's exactly how it works. Is it sits on top. However, if you go to scilabs.com in the next couple of weeks, the official reference design of the optimized circuitry will be available for everybody.
Nice. And just to check, so this has the, well, once you combine it with one of the Explorer kits, you'll have the 22E, you'll have Dracula PV cell, you have EP's PMIC, do you have the storage element as well?
That's a good question. Yeah, I'm happy you were paying close attention. There's one missing ingredient, right? So on this demo, we're using a farm of capacitors.
Okay. Yeah,
so you can solder different ones based on the size of your cell. But truthfully, Dracula is actually a very interesting partner because they have a printed PV and a printed thin film storage.
I see. Okay.
So they can reduce that. So for now, we have these conventional capacitors for different size banks, for different voltage levels. Okay. But ultimately, Dracula and EPs, you solve for capacitance. The same way you solve for battery, you solve for capacitance.
Cool.
So it's a good observation, actually. It was clever.
Cool. Well, excellent. So can you just remind our viewers when you expect this to be out again?
Yeah, so I mean, of course, we're sampling the part now. We have some alpha customers, but this comes out at the end of June. In fact, the GA, we call it general availability, comes out in June, and this kit's coming out at the end of the summer, so you guys can get started, and you can do some very cool dynamic energy-based decisions as soon as the summer's over. It's a good project for a summer intern.
Excellent, and especially while it's sunny.
Exactly, guys, while it's sunny.
Yeah. Well, thank you very much, Tristan.
Thanks so much for having me, guys.
It's been great.
It's a real pleasure.
Where my engineers at?